I've been playing with Docker networking for the past week or so, and I thought I'll make a quick tutorial to show how Docker networking actually works. So we're gonna play with custom networking. I'm gonna spin up a Docker container, put it in a network, gonna spin up another container, put in another network, and we're gonna show how we can eventually make those two talk to each other. We're gonna kind of demystify some of this stuff behind Docker networking. And if you're interested into the details of doing things, this might be for you. Let's jump into it. Okay, let's start by spinning up a new container, Apache web server, and expose it to our host through published port 80, right? Very simple stuff. We used to do this all the time, right? So I'm gonna do a docker run -p. I am going to expose port 80, which is what is running on my container, to port 80 on my host, which is basically running Docker, right? The application that's called Docker, which means anyone who tries to access port 80 on the public machine, Hussein Mac, will be forwarded to this container inside it, right? That request will go right there. Okay? That's basically what publishing really does, port. Yeah. Then I'm gonna do -d HTTPD. -d means, hey, detach so I can do more stuff in my terminal. HTTPD is the image. That's the official Apache image, which is the HTTP daemon. And when we do that, we're gonna get a beautiful new container. If I do docker ps, you can find this is my container ID. I didn't give it a name. It was wonderful feistel. So if I do a curl on my machine, right, it works. If I go to the browser and I go Hussein Mac on port 80, it works. And it only worked because there isn't anyone running port 80 on my machine, right? But this, when we actually did this, the container was placed in a network technically. Right? What is this network? If we do inspect this container, you can basically take the first two letters of a container ID and it will take you, if I can type right. So that's the network. So notice that it's a network, it's a JSON, right? And you can be in multiple networks. Yeah, sure. Why not? So in this case, this container that I just spun is in a network called Bridge, and that's the default network. And this Bridge network that is basically inside this Docker host, right, on my Docker for Mac, has a gateway called 172.17.0.1, and that's the IP address of the container. Now, what happens if I do curl HTTP 172.17.0.2 from my host? You notice that it didn't work. Why? And the reason is because there is no, at least in Mac, Docker for Mac, there is no bridge that takes you from my Mac, which hosts Docker for Mac, down to the container. What Docker does is actually spins up a virtual machine, and there is where Docker actually live, inside my Mac. And in that, if I manage to get into that network, then I'll be able to do it. But from public my machine, I can't do that. If you have Linux, you can easily access that because it will be native installation of Docker, right? Mac doesn't have that, unfortunately. So that's the bridge network. It also means that if you go to the container actually is bridged back out. The container can go out, but you cannot go into the container. That's the only difference here when it comes to Mac. Yeah? And the reason it can go out is because if you, like, for example, you did Google, ping Google from the container, we're going to show how to do that. When you try to ping Google, it's going to do a DNS. Even before pinging, the DNS call will have to go outside, right, to the host. And to do that, you need to go through the gateway, and then you go through the actual host, right? And then the host will resolve. The DNS says, hey, this is IP address of Google, 144.33.1122. And then that will also, the request will go out, right, to the gateway and then all the way to the internet through my MacBook, through the basically the router, my router, and then ISP, and goes all the way there. I need to actually have certain tools to debug my container, right? Like ping and traceroute and its lookup. Containers don't have that by default for good reasons. I don't need these utilities, but I actually do, right? Because I'm gonna do debugging, right? I'm gonna say, hey, where are you now in this thing? So what we're gonna do here is that effectively, I'm gonna build my own image from HTTPD that has a little bit of a fanciness to it. So I built up a Docker file here where I'm gonna inherit from the HTTPD image. And the moment we build the image, right, at the time we're building this image, right, we're gonna build a brand new image from this. We're gonna run apt-get update right there and then, because the HTTPD runs on Debian, right? So very similar to Ubuntu. It's gonna do an update. It's gonna run another run. Again, run. What run does is it will execute whatever command this at the time of building the image, right? The other one is, it's called CMD. CMD will run at the time of running the container, right? So be careful with these two. Yeah. So I don't care about anything here when it comes to running the container. I'm good there. But I want to install IP utils ping. I want traceroute. I want IP route. I want curl. I want telnet. I want DNS utils for NS lookup. I want them to edit, right? So all of this stuff, once you build all of that stuff, I'm going to share it with you guys. You save it, right? You quit, and then you do docker build dot, I am in this location, -t. I'm going to call it in HTTPD. Stands for networked HTTPD, right? So it has more tools for me to do stuff. And now at the time of building all that stuff, everything is cached because I did this before. Now I have a beautiful new image. So what we're going to do is I'm going to remove my container. What was it called? Docker rm 5a. Let's go ahead and delete that. Of course, we're going to stop it first. 5a. And then we're going to remove it. Now let's go ahead and spin up a Docker. And I'm going to start giving them names now. We're going to call it S1, server 1. Okay? I'm not going to publish it right now. And I'm going to spin it up right there. Call it S1. I'm going to detach it. And I am going to call it NHTTPD. Now we're going to create the container from this particular image. Did I explain the difference between an image and a container? Well, very quick. An image is basically the template where you can spin up any number of containers, right? Think of it, if you code and program in object-oriented programming, an image is like a class. You created a class, and then the containers are objects, instances of those class. So containers are instances for those images. Think of it this way, right? So you can spin up many containers, and we're going to do this, right? I'm going to spin up one container called S1 from NHTTPD, which is the one we built. It's identical, but with a little bit tooling so that we can test stuff, right? And I'm going to spin up another one, right? So now we have two containers, S1 and S2, and the source is NHTTPD. So technically, now, notice what I did. I did not publish it to the server, right? I did not publish any ports. So technically, I cannot curl anything, right? Doesn't make any sense, of course. This won't work. It says, hey, what are you talking about? There isn't no path to access these guys, right? But what did we say? When we spin up a container, by default, it goes to this bridged network, right? So if I inspect S1 now, notice that it got IP address 172.17.0.2. It's in the bridge network. If I inspect S2, it has 172.17.0.3, right? So we have IP address 2, IP address 3. And both of them are in this network. And another way to do this is you can actually inspect the network that's called bridge. I think that's how you do it, right? Or is it flipped? No, that's right. If you inspect the network, you can see all your networks. And we have one network currently, it's called bridge. And this bridge network has two containers, S1 and S2. That's another view to view your containers. So now, you notice that how many users will be spin up containers, and everyone will go into this default bridged network, right? Could be bad if you have sensitive containers with sensitive information. That's why we're going to learn how to spin up our own custom network and then put our stuff there. But still, too early for that. So how about we actually bash into my container here in interactive terminal, it's called S1, and bash into it. Now, if I do that, I can ping google.com. Wait a minute. How can I ping google.com? That's actually interesting, right? I am inside the network. That's called bridge. My IP address, this is my host name. It's gibberish 849. And this is my IP address, 172.70.02. That means the reason we got access to the internet is because of our gateway. Our gateway is .1. And our gateway in itself has another interface that exposes it to my network, which is my MacBook right here. And then my MacBook is connected to my Wi-Fi, which is connected to my router, which is connected to my ISP, right? So there is like a line that takes me right out there. And the way it works is just the default gateway concept, right? If you're going to google.com, this is the IP address. How does networking work? It says, hey, every network has very simple logic, at least locally, right? I want to go to 142.250.217.142. It will ask this question. It will do a subnet mask on itself. It says, okay, is this guy in my subnet? How does it know that? Basically, it does a /16 on its IP. That's basically where the subnet mask is, right? So my subnet mask is 255.255, right? Because it's /16. .0.0. So we'll do that. 255 to 255, do an AND. Is 142.250 the same as 172.17? Nope. Nope, that's not. Definitely. The moment it says, nope, all bets are off, it sends the IP packet to the gateway. And the gateway will just do the same logic over and over again until eventually the packet will reach someone who is in its known network. It's not quite that way in the internet. It uses something called the BGP, Border Gateway Protocol, but that's outside the discussion here for now. But yeah, that's basically the simple logic, right? So now, cool. I can ping S1, which is, wait a minute. I'm pinging S1. I can't ping S1. How about S2? Can't ping S1 or S2. Why? Well, if you think about it, let's do an NS lookup. Yeah. NS lookup basically the way to give me the IP address. What is the DNS address for Google? Look what happened. It gave me the IP address, right? We're going to come to why I couldn't ping my containers, right? In a minute. When I did an NS lookup, this was the DNS server that hosted me. I have no idea what's this because that's not my subnet and my host. My subnet is 192.168.255.254, right? So this is what this is actually, this is the VM that I talked about. This exists inside my Docker for Mac, and that is basically where Docker is running, right? And that is the DNS server for Docker when it comes to bridging the internet. So if you want to do any DNS, it goes to this query, right? Why? Because that's the bridge network. The bridge network lives there. And as a result, all the DNS query will go to that. Well, that's why when I do a NS lookup on my own host name, S1, you might say, Hussein, S1 is not really a host name, right? Well, we can do this, right? NS lookup and then do this same thing. Even that one won't work. And the reason is because that query goes to this. Well, think about it this way. This query, this DNS query will go where? It will ask the same question. I need to go to 192.168.1.65.5, right? Where is this? It's not in my subnet. Same question, right? It's not on my subnet. Let me set it to the gateway. The gateway is 172.0.1, right? And that will take you out to this until it reaches the host, the Docker host, which is this guy. Now this guy is going to ask the question, what is this DNS? It doesn't know, because that is, you're asking someone outside your network for your hosts that are using on your network. They don't know that. And that's the why you cannot access things by host name inside the bridged network, because the DNS is just outside, right? And that's why, but if you want, you can ping the IP address normally. You can ping yourself. You can ping this guy, the gateway. You can ping 3, which is the other container. That's definitely fine. You can curl 172.17.0.3. Yay! That is pretty cool, right? And that's myself. We're going to change them so they give you different results, so we know where are we, right? We're going to do that right now. I am in S1 right now. Okay? So now I cannot access anything by hostname, which is very limited, right? That's the limitation here. But we can definitely access by IP, right? And the problem here is also, you not only you can access by IP, everybody in this network can access your stuff. Nope. We want to limit that, right? So let's go ahead and actually change a little bit here. I want to go to the, what is it called? The htdocs here. And there's an index.document. And I'm going to change it works here to call it, yo, this is S1, right? And then I'm going to exit here. I'm going to do the same thing with S2. Go to the S2. Go to htdocs. And then index.html. Go to that, and then I'm going to change this to S2 so we know. All right. Now if I curl 172, what was the IP addresses again? I keep forgetting the subnet. If I curl 172.70.7.3, this is S2, this is S1. Cool? That's nice. I like this touch a little bit. All right. Again, these are containers that are inside the network, and they can only talk to each other, right? And very limited by IP address, not by hostname. Why? Because DNS is going all the way to the host and trying to figure out things, and it can't, right? So how can I fix that? Okay? Let's fix that. Well, fixing that is not hard. We can actually create a network. Let's go to Docker network, create, and we call it I don't know, backend, whatever, right? And when you do that, right, you can actually do so many fancy things, right? One of the things you can do is actually specify a subnet. Right? You can go by the default subnet, so it will generate a subnet for you, but we are fancy people. So what I'm gonna do is actually generate a subnet, and that's my subnet, right? So what I'm going to do is, how about we generate subnet 10.0.0, and let's make it /24, right? Which means this and this and this, 888, right? This is the network, this is the host. So I get 255 containers per network. Plenty, more than enough. And then I'm going to call it, did I call it right? That's it. I think, do I need anything else? No, I think that's good. Just like that, we created a network. Now this network, if I inspect this network, it doesn't have anything, right? Call it backend, right? This is my subnet, and it doesn't have any containers. So how about we actually connect my containers to this subnet? Well, how do I do that? You do Docker network connect the network, which is backend, and the container S1. I want to connect S1 to this guy, and I'm going to connect S2 to this guy. I don't know if you noticed this, what's going on here, but we're gonna come to that now. If I do docker inspect docker network inspect the backend, you'll notice that my Docker's got an IP address 2.3. You can also set a bit here in the network says, hey, this network is internal. That means only the guys inside this network can talk to each other. Nobody, they cannot leave the network. Even if there is a route that says, hey, go to this network, nope, they cannot leave it. So what we did here, if we inspect S1, for instance, notice what will happen here. Look at this. S1 now belongs to two networks, right? This guy and this guy. No, we don't want that. And this is a mistake I made a couple of times where I was like, oh, I connected this network, but it is still connected to other network, because you can absolutely have two network cards in a machine, right? Think of it, the container very similar like that, right? And if you think about it, the container is just a process that happened to be in its own namespace, right? Which means they have limited set of resources, and you can add and remove resources so that other containers, other processes cannot see it. And you can add it to a control group to also limit. It says, okay, you only get this much of the CPU, and you cannot exceed this much memory. That's basically how containers work in a nutshell, right? Control groups and namespaces. Just isolate them from the word. Okay, now I need to really remove those suckers from the bridge network, right? So I do docker network disconnect S1. No, the network first. Bridge S1. Remove from the bridge. Remove from the bridge. Now those suckers are alone in this network. Right? Let's inspect it. I suppose you can do a docker inspect the backend. It's just better to add network to know that, hey, by the way, I'm inspecting a network, but Docker actually overload that operator to inspect both containers and networks. Look at this. Now we are alone, my friend. Okay, Docker execute -interactive terminal. I don't know if it stands for interactive terminal. This is how I remember stuff, by the way, guys. You're gonna see weird stuff. That's how I remember, by the way. Bash. I'm gonna bash into the container. Now I do ns lookup S1. Boom. ns lookup S2. Boom. It works. Look what happened. Look at this. The DNS server now became this local instance in the container. That's 172.0.0.11, and that's local. This is loopback effectively, right? So now that is why we were able to resolve that S1, which is technically not the host name even, to the IP address. Docker knows. Says, okay, now that we're on your own network, you're going to get your own beautiful DNS provider. Actually, every container has its own DNS provider. And technically, they are all connected to each other somehow. They share information, because if I add another container to this network, automatically the DNS knows about this. Right? Alternatively, I can also use this, Docker ns lookup, this guy. And that also answers me because that's the actual host name, right? So now I can do curl HTTP S1. I can do curl HTTP S2. And now if you have like Nginx or HA proxy running and you spin up a configuration and you put Nginx within the same network, beautiful. They see each other. You can use host name inside Nginx. Why? Because the DNS resolver is that thing. Is not going outside and trying to figure out what the DNS is, right? If this was like a public thing, you have your own domain server, and that's a good idea sometimes, where if you have like in the cloud and you have your own DNS server, and many of you followers of this channel are sophisticated DevOps, You probably have done that. So you probably have a DNS server, and that DNS server knows about every single entry, an actual legit DNS server, you know? And you can add entries there. You can add fancy thing. It's like fancy.blancy.com, which doesn't exist in the internet. Well, maybe it does. And that can point to your local container. Sweet. So we did that. We built a bridge. They can talk to each other right now, right? Beautiful. They can curl each other. The containers also have access to the internet. This is something that you might not want to. So if you want to actually disable that, you can create the network with a -- internal, right? And that will isolate it from the bridge. Right? What does that mean? I'll give you an example. If I do a trace route to S1 right now, right? It goes directly there, right? If I do a trace route to S2, it goes directly there. Why? Because it's in the same subnet. If I do a trace route to something above me, right? A trace route to my router, my actual physical router, to 192.168.254.254, right? This is my router that is actually sitting on my network, right? It can find it, right? And the reason is because, well, what is this? I don't know. It's not in my network. It's not in my subnet. So it was like, okay, gateway, take care of it. Where's the gateway? That's the gateway, 10.0.0.1. Who assigned it? Well, the bridge did, right? The network, when we created it, it created a bridge. And the bridge has a default gateway, by the way. And that's why we started the containers with 2 and 3, because 1 was reserved for that. Yeah? And there was many articles, by the way. I would like to have access to that sucker. And I would like to configure the gateway. I would like to make a container my own gateway. Docker don't let you. Right? I know when I tweeted this, a lot of people asked me about Podman. I think, was it called Podman? The replacement for Docker. I never used it, but it sounds promising because Docker's, dude, is so restrictive, dude. There's so much restriction when it comes to these things. Even the internal network, we talked about it. Well, the moment you do it internally, you will not have access to the gateway, right? But you will also not have access to other networks. Why? If I added a rule, follow it. It's just all or nothing when it comes to Docker. They don't have like a middle ground. It's like, okay, dude, all right, I want an internal network. I want another internal network. I don't want a bridge. I just want these guys to talk to each other and want to talk to another network, because this network is a database network, and this network is the web servers, and the other network is the reverse proxy. And I want certain networks to talk to each other, but not everyone. But I don't want them to connect to the internet. I couldn't find a way. Maybe someone will let me know in the comment section, but I couldn't. Anyway, so you notice that it goes to the gateway, and the gateway says, oh, I don't know this. Let me go to my gateway, right? And that gateway basically will take me to the default gateway, which is network. I can do the same thing with my other machine, which is .10. Same thing. Yeah. So we go to this, and then this will land me in the network, and that network basically will take me to my host. Right. So this is how it works. Now, and this is where I need to blank things out, right? Just so I don't show my IP address, public IP address. If I do google.com, yeah, same thing. Goes to my network, goes to the router, goes to my public IP address, which you cannot see, right? And then goes to another public IP address, which is my ISP, goes there, up until we find the actual gateway. How does trace route work? I talked about it in my networking course. It's basically a bunch of ICMP messages going back and forth, right? You set the TTL, and then the shorter the TTL until you reach the next hop, right? Because IP packets, every time an IP packet is routed, the TTL, the time to live, is decremented on the IP header. And that's a nice game you can play with trace route. So now that's the path. So if you cut the path, if you cut that bridge, the gateway, you have no access to the internet. And that's how you basically can do it. Yep. But we're not going to do that. All right. So now I have, not PS. ls. Oh, I'm in the wrong thing. Of course, that image doesn't have Docker. If I do Docker network ls, you can see that I have now my backend bridge, right? My backend network. What I wanted to do is effectively spin up another network and put S2 there and see what will happen, right? So I spin up two network, right? The other network is going to have a different subnet, and I want them to talk to each other eventually, right? They're not going to be talking to each other, and we're going to talk about why effectively, right? But let's do that. Docker. Hopefully the command is still there. I didn't write a lot. There you go. Thank you so much. Backend. I'm going to call it backend 2, right? Or maybe we can call it front end. Front end. And you might say, Hussein, why are you doing this? Why are you creating two network? Well, it's actually a very common thing you do in production, right? Where let's say you have, I'm going to draw a picture here. You're going to see the picture here. Where we have, let's say you have Nginx or HA proxy or Envoy or something that talks, an API gateway that talks to the client directly, right? And you have maybe 5 instances of those to load balance, right, through the DNS. And those talk to load balance on the backend with a bunch of web servers, right? And those web servers turn around and talk to the database. One configuration might be put everything in the same network. You can do that. But why is that not a good idea generally? It is because Nginx or it is very dangerous to expose this publicly. The attacker, if they compromise Nginx or the gateway, they got access to your entire network. There is no other line of defense. The only line of defense is there and that, right? So what we do effectively is put Nginx and all the load balancer in its own network, right? Put web servers in their own network and put the databases, definitely, the precious data, in its own separate network. Why do you see all the headlines, 7 terabyte of Elasticsearch or MongoDB or Postgres database has been leaked? Because people don't do any of this stuff. What they do is like they spin up a Postgres instance on Amazon and they make it public and they listen on interfaces. So that's why it's publicly accessible for anyone. That is a really bad idea. That's awfully, of course, the extreme, right? But what you can do as a network administrator, I'm not a network administrator. I just love this stuff, right? I'm a backend engineer. But what you can do is effectively play with this thing. So I want to simulate this in Docker by creating multiple network that I want certain rules to be applied. So this network can talk to this network. So that's why, right? So let's call this is the front end, that's the back end. Right? So I'm going to create the front end network now. Pool overlaps. Oh, what the heck? Of course. I just said enter. It's the same subnet. What we're going to do here is actually add one here. So now this is my subnet 10.0.0. So that means the first one is 10.0.0.1.2.2 up to 255, right? The second one is 10.0.1.1.2 up to 255. So you have two different unique subnet effectively. Now it's not yelling at me. Sweet. Now we're gonna take that sucker, disconnect S1, disconnect S1 or S2. Let's remove S2. S2 from the back end, right? And then connect S2 to where? To the front end. What did I do wrong? Yeah, I spelled connect with 3 N's. Genius. Nice. Now, Docker inspect S2. It has IP address 10.0.1.2. Docker inspecto S1. S1 is just this one, still the same thing. Well, let's bash into S1 and say ping S2. What do you mean I can't ping S1, S2? Well, the reason you can't ping S2 is because it's not in your network, all right? Because what happened is, well, in this case, it's a little bit complicated. So let's do, what was the IP address? 10.0.0.2, I think. Let's exit and confirm. Just do hostname -i. That's the IP address, right? So what we're going to do is just ping 10.0.0.2, right? Which is the other. I'm in S2, right? Which is this IP. I want to ping that. That won't work either, right? And I went to the extreme. I just did the host name. What happened with the host name is like I couldn't figure even what your IP address is, right? So the DNS failed. Here, well, you don't have DNS. You have the IP, but you couldn't figure out how to get there. Why? Because it says, all right, I want to go there, but what's my gateway? My gateway is 10.0.1.1, right? And I took it there. I'll take it there, but the gateway doesn't know how to forward it. It says, okay, I'm going to go. I have no idea how to do this. I have no idea how to reach this network because the gateway doesn't know. Okay? So we need someone who knows. We need a router. We need to create, right, a router. So we need a router. So we're going to spin out our router, our own gateway, docker run, -- name. I'm going to call it GW, the gateway, right? Router. What should we call it, router or gateway? Let's call it a gateway. Let's call it gateway, GW. You guys know. This is going to link us from the front end to the back end and vice versa. Okay? So now docker run -- name. I don't need to publish anything. The host has nothing to do with this. What are we going to do? I want the gateway. By the way, you can, while creating a container, you can assign it a network. And I want the gateway to be in my backend network. Okay? For now. Because I'm going to add it also to the front end. Yes. This router, this gateway is going to belong to both network. Why? Because this will be the route. It will route us from one place to another place. Okay? Very beautiful. So we're going to detach it. Again, our NHTTPD, which is our beautiful custom image container here. And I think that's it. I don't think I need anything else. So this net. Again, okay. And I lost it. Docker and -- name, gateway, -- network, backend, -d, and no HTTPD state. Sweet. Now we have the gateway in the backend network, but that's not enough. Docker network connect the front end to the gateway. Can I do it both? I never tried to add two networks in there. I probably can. Probably can do -- network backend front end and it will work, but I never tried it. So you guys feel free to do that. So now, that's still not enough, you guys. We're going to find out. If I bash into the gateway, right, and I say ping S1, it found it. Ping S2, it found it. Why? Because if you're looking at the graph, yeah, S2 and S1 are right there, right? Because they are in S1. I found S1 because my DNS knows about this network. It's right there, and I found S2 because my DNS knows about S2 is right there. It's another network. That's why it knows about it. But technically speaking, the other guys don't, right? So if I exit now and I go to S1, S1 still, of course, cannot ping S2, right? And vice versa. It cannot know. It doesn't know, right? It does know the gateway, right? Because it's in its network from this side. And the other guy, S2, it also know it can ping the gateway because it's in its network from the other side. But they can't talk to each other. So here's where the final piece. So do we know what we're gonna do now? Hostname -i, that's my name. I am S2, right? NS lookup, I can do a gateway. That's my gateway, right? So what I want to do effectively is I want to add a rule such that IP route add. I want to add a route in my host as S2, such that if anyone want to visit this network, which is /24, they have to go through this gateway because it's a different gateway. And that's what we need to do. This will fail because I forgot something important to do. The reason this will fail is because this is an administrative operator, right? And you cannot add it. You have to start your container with the ability to change administrative setting, right? So I have to restart the container S1 and S2 with the flag that is called cap add equal net admin. And that would be a good thing to do, right? How about we do this again, right? It won't hurt. Docker stop S1, Docker stop S2, Docker RM S1, S2. We'll spin them up. We're not afraid. All we have to do is just literally Docker run -- name S1, and then the network is that's the backend, right? That was in the backend, and I want the spin up with the administrative option cap add, right? Equal net admin, right? And then -d http d n, right? So we have a networking access. Sweet. So now I'm going to spin up my first network. Did I forget anything? Nope. I'm connecting it. So this way I'm going to spin it up and then we're going to learn something right here. We're going to spin up and also connect it. Beautiful. Do it. Up. And now this guy is going to be in the front end, right? Let's do it this way. And this is going to be S2. How about that? Like nothing happened. Did we get the same IP addresses? Probably not. No, we get the same IP address because it was released and then we got it back. Sweet. Now let's bash back into the container. S1 bash. Now hostname -i, right? So that's my first. I want to do a NS lookup. What's your gateway? And let's add the rule. So now I say, hey, in my S1, if someone, right? Oh, let's go to the other container. Docker execute -it S2 bash. I'm gonna do the same thing. So I can see every IP here. NS lookup gateway. Ho. Now I am in S2, right? That's my gateway. That's supposed to be my gateway, but it's not really. In the network, it's not my gateway. My gateway is something else. I want to add a route to send packets this way so that it can reach anyone in that network. How do I do that? IP add route, right? Oh, sorry, it's our IP. How do I do that? IP route add. If someone is going to 0.0.0.0/24, any IP address on this network, please forward them to 10.0.1.3 instead of the default, which is 10.0.1.1, right? Because that's the default gateway. Now I'm adding another route, if you think about it, right? You can actually change the default gateway so all your traffic goes there, but no, we don't want that. Certain traffic still need to go to the default gateways for internet access. Because if you change the default gateway, this gateway will get it and it will be confused. It might actually still work because it will be. I see if this is a very good idea. So you can have a centralized place for all internet access, and you can do logging and monitoring. Dude, a lot of stuff, man, you can do. Now, if I do a trace route on 10.0.0, let's do this 10.0.0.2, right? You notice that, look what happened. We want to go to 10.0.0.2. We correctly followed the route. Says, hey, I'm going to go to 10.0.0.0.1.3. And then we drop dead. Why? Right? If you know how trace route works, right? Ping will do the same thing, by the way. Ping will just say, hey, I couldn't do anything. The reason we couldn't get a result is, yeah, you added a route to take you to the gateway from S2, right, network, but S1 has to respond, right? So I would guarantee that gateway actually took the packet all the way to S1, and S1 tried to respond, but it couldn't. It says, hey, I want to respond back to, what is it, 10.0.1.2, right? That was my IP address, 10.0.1.2. But it couldn't because I don't know how to forward the message. S1 couldn't. So what we can do is go back to S1 and add a very similar rule so it can know how to forward the packets back, right? Networking is not magic, my friends. It's all logic. IP, route, add. Now, if someone wants to go in this network .1.0, please go via 10.0.0.3, right? That's my gateway from this side, right? Because remember, everyone sees the gateway as a different IP address based on their network, right? And I'm gonna draw hopefully the pictures, and I show them as in this, and you can pause the screen as you go there. Beautiful. Now let's do ping 10.0.1.2. Hoo, works. Curl 10.0.1.2. Nice, right? This is it. It works. Why does it say? Oh, we didn't change it. Because remember, we changed it and then we deleted the container. But remember, just take my word. This is S2, right? Right? A problem is like we cannot do curl S2 still. And the reason is, maybe we're going to make another video, it's because technically DNS is still not aware of this thing. Yeah, DNS is a slightly different beast in this scam. It couldn't figure out how to route this traffic. So there is another route I'm missing probably to propagate DNS so that everybody knows about it to everybody. But yeah, so this is one limitation of my tutorial. So we'll figure it out eventually. Maybe it's not possible. So now if I go to S2 and I say pingo 10.0.0.2, it works. If I do curl, works. If I do ns lookup 0.0.2, that doesn't make any sense. If I do a trace route 10.0.0.2, look at the path. That's pretty nice. Pretty neat for me. You want to go here. We're going to take you to this gateway. And then that took us through all the way there successfully. Okay? The only missing thing is the DNS. And I couldn't figure it out, how to propagate DNS. All right, guys, I think we're going to stop here. This is a huge, large tutorial. Hope you enjoyed. I'm going to see you on the next one. One missing piece before we end it. You can also add a script to add these rules every time the container restarts by adding a script at the end of the Docker run. I didn't do that, but it's possible, right? Because these IP route thing are ephemeral. The moment you restart the server, the container, they are gone, right? And yeah, one more thing. I know that you can all do most of the stuff with Docker Compose, but I thought I'll get a little bit dirty and do it manually by hand. It's just, I just like to know how things work. Yeah, I gotta use the Docker Compose. I don't like YAML, but yeah, it's just another way. This way you can actually see exactly you're building everything by hand. I like building things by hand. It could be just me. You can have, of course, use Docker Compose to build everything with one single script and just spin it up. But what is the fun in that? There is no fun. There is no joy. Right, back to the video. So yeah, I thought I had fun doing this stuff, so I thought I'll share it with you guys. Hope you enjoyed this video. Gonna see you on the next one. You guys stay awesome. Goodbye.